Even massive ships can remain stable in adverse weather conditions with today's technology. Not only that, but some ships designed by engineers can even self-right when toppled. Hi, I'm Eli the engineer. Come learn with me today some of the technology that keeps ships afloat on dangerous seas. When a ship sails on the sea, it is subjected to a variety of forces and pressures from the waves and wind that could potentially capsize the vessel. Engineers have developed ingenious stability systems to protect cargo and precious lives. Bilge keels are one of several technologies used to keep ships stable. Bilge keels have a stationary wing or fin-like shape and are mounted on the side of the ship's hull. The bilge keels reach roughly 2/3 of the ship's length and boost the ship's stability as it goes faster. Eli's factoid, the MV Estonia tragedy. On September 28, 1994, the MV Estonia, a passenger and car ferry, sank in the Baltic Sea while en route from Tallinn, Estonia to Stockholm, Sweden. The ship capsized and sank rapidly, leading to the loss of 852 lives, making it one of the deadliest maritime disasters in European waters during peacetime. Another clever stability device is the anti-rolling tank, which is a tank that is positioned across the breadth of the ship and acts to stabilize the ship's position when the ship tilts to the left or right. When the ship tilts to the right or left, water flows in the tank, considerably lowering the ship's rolling motion. There are two types of anti-rolling tanks, active and passive. The mechanism for water flow in an active rolling tank is more complex and employs a pump. The active fin stabilizer, which is structured like a fin and acts to lessen the ship's rolling or tilting motion, is the next type of stability device we will explore. The fin stabilizer is mounted on both sides of the ship's hull and may move in a variety of directions, which are controlled by the ship's sensitive gyroscopic system. When the ship is rolling or tilting, the sensitive gyroscopic system transmits an electro-hydraulic signal to the activation system. However, active fins are ineffective when the ship is traveling at less than 10 knots, or around 18 kilometers per hour. Guys, I have a special gift for you. We partnered with Audible to get you a free book on the 50 greatest engineers of all time, free with a 30-day trial. Grab it today, my fellow engineering nerds. Link in description. Anti-heeling system on container ships, which is a servo control system meant to keep the ship horizontal throughout port loading and unloading. Anti-heeling cannot be utilized as a stabilization device on the high seas and can only be employed when the ship is docked and loading and unloading containers. The anti-heeling system detects the ship's angle of inclination and automatically balances it by putting water into the ballast tank from right to left or vice versa. The anti-heeling system is made up of a primary control panel, a pump start panel, and an anti-heeling pump, and its performance may be controlled both automatically and manually. Eli's factoid. On September 6, 1622, the Nuestra Señora de Atocha, a heavily laden Spanish treasure galleon, sank off the coast of the Florida Keys during a hurricane. The Atocha was part of a fleet of ships that carried vast amounts of precious metals, gemstones, and other valuable goods from the Spanish colonies in the New World back to Spain. The shipwreck resulted in the loss of an estimated 40 tons of gold and silver, making it one of the most significant maritime treasure losses in history. Search and rescue SR vessels are a critical aspect of maritime operations, offering aid to victims of maritime accidents at sea. Extreme weather and heavy sea waves, on the other hand, can impede SAR operations and perhaps cause the ship to capsize during these rescue efforts. Engineers from throughout the world have constructed rescue ships based on the notion of self-righting boats, which can return to their former position even after being flipped 180 degrees. Self-righting boats, in addition to being able to right themselves, may attain rapid speeds and resist a variety of extreme sea conditions. The Royal National Lifeboat Institution, RNLI, in the United Kingdom is one of many companies that build these self-righting boats. There are numerous critical components to building self-righting boats that can flip back on their own. The first part is the ship's original design, in which all heavy equipment and objects must be placed as low as feasible within the ship, lowering the ship's center of gravity. The second component is the crew's operating and control compartment, which must be light, sturdy, and airtight. Additionally, the crew access door must be watertight to prevent water from entering the area if the ship capsizes. A pendulum system is also used on self-righting boats to prevent water from entering the ship's interior. When the self-righting boat capsizes during operation, the weights in the pendulum system hang vertically, causing all open sections to close automatically and prevent water from entering the ship. These self-righting boats also include an inbuilt device that detects capsize. This device secures the boat automatically by turning off the radar and engines before returning it to its original place. The radar and engines will restart once the boat returns to its regular position. Well guys, that's all for today. Don't forget to grab that free book from Audible on the 50 greatest engineers of all time. The link is in the description. Eli the Engineer, signing out for now.